So cell volume regulation is really complicated. It has to do with all of these things, but we're going to concentrate on the osmolarity and how cell volume changes with the osmolarity of a solution, okay? I'm running out of time. Bear in mind that permeant molecules have no effect on cell volume, and if I get a chance, I'm going to take you through a sample and show you why that is. If it crosses the membrane freely, it is not going to have an effect on the cell volume, because eventually the concentration of that molecule is going to be the same on both sides of the membrane, and you won't be moving any water. It is the impermeant molecules that you have to pay attention to, because those don't diffuse across the membrane, so water diffuses instead. So I have a cell, and I drop it into a beaker. X is permeant to the membrane, Y is impermeant, okay? So I have 200 millimolar of X inside the cell and 100 of Y inside the cell, and I have 100 of each outside the cell. So first of all, if I talk about the solution outside this hypothetical cell relative to the solution inside, is it hyperosmolar, isoosmotic, hyperosmotic, isoosmotic, or hypoosmotic? It's hypoosmotic because I have fewer milliosmoles per liter on the outside than I do on the inside. So I say that the outside is hypoosmotic relative to the inside, okay? I have 200 milliosmoles here, I have 300 here, okay? Now, X is permeant to the first thing that everybody says who has any common sense is the cell is going to swell in this case, because the water concentration inside that cell is less than the water concentration outside. But notice that X goes through the membrane, okay? So what happens is X moves from inside the cell to outside the cell. And eventually you get the same concentration inside and outside. So now, if I have the same concentration of X inside and outside, and Y is my impermeant molecule, and it's the same on both sides, now what's the tonicity of the solution? Will the cell swell, or will it shrink, or will it be the same volume as when you started? It's the same. Good. If this volume on the outside of the cell is very, very large relative to the volume inside a cell, which is ordinarily going to be true, then what's going to happen is, for all practical purposes, the concentration will be 100 on both sides of the membrane. And in fact, if you add it up, 200 on the inside, 200 on the outside, what we have is a solution that is isotonic. So if you're holding a bag of X and Y, and it's got 100 of each, and we're dealing with cells that have X and Y, where you start with 200 and 100, and I asked you about the solution, you would tell me that it is hypoosmotic, but it is isotonic, because biologically it's not going to cause a cell to swell, okay? But physically, if you add up the number of milliosmoles per liter, there's a difference there, all right? The computer program has a lot of problems like this. Go through the index, you'll be fine, okay? All right, let's wrap it up then. Thanks.